So let's get going here. Welcome to RWX Rob GG again. This is another video that I actually planned to do. This video is going to involve Bash and Rust. So if you want to watch what's going on, I'm using Bash as an example of an interpreted language, and I'm using Rust as an example of a compiled language. You could equally do Python versus C. Versus is, I got to tell you, versus is not really, it's a little bit of a clickbait title. I admit it. It's not really versus. They're two different tools for two different purposes, and they really go together. We've actually talked a lot about sort of the rapid increase in interpreted language usage to over, so from 2000 through like 2013, and then the massive sort of like movement away from interpreted languages now that LLVM came in, and then we started seeing lots of compiled languages: Go, Rust, Crystal, Julia, a bunch of compiled stuff. And I'm going to save that for another video. I have done another video already that covers kind of my take on the history and how we kind of moved through interpreted languages. Have come full circle back to compiled languages for the most part, but not entirely. I mean, there's still a lot of value in interpreted languages. So what does that even mean? That's what this video is about. And so, scripts versus programs, those are words people use versus all the time against each other. And so we're going to talk about what that means. I'm not going to go deeply into Bash. I'm not going to go deeply into Rust, but I am going to show you the differences between the two. So, in fact, let's jump right into it. I do have a Twitter post that I just recently made. I'm going to pull up right now. So I just put a Twitter post here. Again, twitter.com/RWXROB. There is definitely a reason we have interpreted languages and compiled ones. So just quickly, rather than showing you how these work and everything, I'm going to use these screenshots to show you the difference. Both of these programs do the same thing. In fact, I'm going to go show you what they do. I'm going to look into my little challenge directory, and this is Hello World. So this is I'm kind of giving away one of the challenges. So this is something you should know about me. We plan on doing RWX.GG will have a lot of challenges based on the language. I like challenge-based programming because it helps you learn in a fun way, kind of a gamified way. And so the first challenge for Rust, which I was doing the other night with Gabe actually, and we were playing around with Rust. We're new to the language, so we thought we'd have some fun with it. And here, let me just write up the challenge for you so you can get an idea of what it's about at the same time. I'll be going through all the challenges, walkthroughs of the challenges eventually, but this is what it's doing, and then I'll run it and we can see, and then we'll show you the difference between this language and the other language. So we're using an actual example instead of just me, talking about it. Okay, interpret means somebody else's program. How many should I know? Just curious. I'm stuck with C, C++, and use Python to do simple scripts. That's a big question. Which language to use? If you go to rdbx.gg/lang, L-A-N-G, I've got a write up there of the languages I feel like everybody should learn first, and why. And so if you want to, if you want to read through that list, you can understand. I believe picking a language is largely about understanding how languages work when you're a beginner, rather than getting a job. But it depends on what your needs are. Right? If you need to get a job immediately, then maybe you want to learn, just Go to get that job at that company that you want to work at that has an internship open right now, or something like that. Rust might not be your first pick because there's not as many jobs in Rust. There are more now. Anyway, so let's talk about what this challenge is and how it relates to the Bash one. In fact, I'm going to go back to the well, you know what? It's more fun to reveal how easy Bash is compared to Rust. So we'll do it that way. So install the Rust language tool. So this is the challenge, a Hello Rust challenge. Create a Hello World Rust command using only Rust C, which is the compiler. So the first thing to know about, you like those Elvis, Mike? Thanks. It's a Shure 55, classic. So if you know anything about languages, computer languages come in two styles. There are interpreted languages, and then there are compiled languages. The fact of the matter is that all languages are compiled if you really are pedantic about it. It just depends on what you have to do. So as a developer, as a programmer, when you work with a compiled language in the common vernacular, that means that you are doing the compilation yourself. You're running a compiler, and the resulting binary file is what you get. And I'll show you about that in a second. When you are using an interpreted language, you just type the commands and run it, and it works. And in order for that to work, though, you have to run an interpreter. And the interpreter is interpreting all of those things for you. The interpreter itself was compiled. And in some cases, the interpreter will even compile your language before it runs it, such as Python, Perl, no, actually Perl doesn't do that. Python does that. Java does that. So compilation is the act of taking, what about, yeah, Verilog, yep. So compilation is the act of taking code that you understand as a human, more or less. You'll see it's sometimes harder to understand than others, and turning that code, that your human code, into machine code that can be directly injected into memory, given to the kernel and run. And that, even that code is sort of interpreted at the low level, but into system calls, which go into the kernel and tell the kernel to do different things to different devices on your computer. It's very, very low level stuff, but all you really need to take away is that, as far as you're concerned, when you use a compiled language, you are using a compiler to turn it into a binary, and then that binary can be used anywhere. Why would you do that? Well, you're going to see it's actually a lot faster for it to execute because it's already been converted into machine language. It doesn't need to be done. It doesn't need to be converted every single time that you write it. And that is the single biggest difference. So let me just state the single biggest difference between an interpreted language and a compiled language is speed of execution and speed of startup, but more importantly, speed of startup. So once the thing gets going, like Python's very good at this, once a thing gets going, it's pretty fast, right? Because it's already got all of it interpreted into the computer brain, and so it's really fast. But interpreted languages are almost always way slower to start up, because the step of compilation that made it into a machine code that could just be run is effectively, not directly, but it's effectively done every time you run it. And that's why there are some languages that kind of fit in the middle, and we maybe talk about them a little bit. What they do is they actually compile your hard to parse code from a human into something that can be compiled even faster later on. It's called bytecode. Yep, there you go. Have just-in-time compilers as well, right? So there are, and so that's what I was kind of getting at. I want to make sure everybody understands that there are languages. Java is another one that has bytecode. Python, Lua. So there are languages that have a middle ground between being fully compiled and into machine code, and which has its own runtime, and and being interpreted, having every line interpreted and then run as however the interpreter sends that to the kernel to be run. And so, so that's a lot of talk about it. Let's see what this looks like and why you care. So the reason you care is because when you pick a language, you're picking it for lots of reasons. But if you're picking a language that's robust, that needs a lot of speed, and it's going to get big, you might end up reaching for a compiled language. Compiled languages almost always are strictly typed, not always. And what that means is it's harder to make a mistake. And there is no language on planet Earth that is harder to make a mistake with right now, I believe, than Rust. In fact, it was designed from the ground up to not allow you to make mistakes at the cost of clarity. It's actually very hard to read, and we're going to show you right now what Rust looks like to just do a basic thing. Okay, so this is the challenge. The challenge is for us to write a Rust program, hello.rs. You'll notice I have a suffix here, and you may have watched other videos where I rant about suffixes. Ada might be more safe. That might be. I would have to look. That'd be a fun comparison spiel if you want to look at that one. But in terms of like C compatible languages, right? It is compatible. Anyway, so hello.rs. So first of all, you're going to see this has a suffix. Don't you hate suffixes? Fish.sh. No. Okay. So first of all, this is not the final result for the command. The .rs identifies it as a source file that can then be compiled, and the resulting program will be ./hello or hello, so we can run it that way. We just want this thing to print hello world, so this isn't that big of a deal, right? However, after it's got a few other steps in here that I won't go into unless you want. I guess I could probably go into them. Which is C to the opposite side. Yeah, C is definitely one of the most dangerous languages to write code in. Format it with Rust FMT. So Rust FMT takes away the hassle of making the tabs versus spaces argument. It just goes away. Compile it with Rust C directly. And if you know Rust, you know that that's not common. Usually people will use cargo for that. And run it with /hello. Then, if possible, add Rust FMT to your editor so that it automatically formats your code to save it. It's an extra step I won't be going into here, but I can show you how to add the Rust FMT line to your vimrc. I'll do a separate video on that so that your Rust code automatically formats every time you close it out and save it. Replace world with a variable. Now, this is where it gets interesting. And now replace world with the first command argument so that /hello space first prints hello first, and /hello space in quotes first last prints hello first last. Finally, print hello world if there are no command arguments. Okay, so in other words, we have an if statement. We have a condition that says, hey, I didn't get any command arguments. I'm going to go ahead and print just hello world as the default. So if you know programming, this is like one of the most basic things you can do. You may be new to programming, so you don't know what a variable is. If you've done any math beyond algebra, you know what a variable is. It's just a way to store some data of some kind and then use it. So I'm not going to do any instruction about programming here other than to demonstrate the difference in speed and size. So this is a knowledge node that I've written in YAML, as I've said before. Oops, I need to fix that. And it does have some of the workthroughs of how to write this. It's not currently available, but it will be soon. So let me show you what this code looks like. So this is the final resulting code. So when I run this code, I'll show you. I do hello, and it does hello world. If I do hello Rob, it does hello Rob. If I do hello Rob Mulstein, it says just hello Rob because it only grabs the first argument. And I put the quotes around it, and it does the whole thing. So that's all it's doing. Okay, I have to show you what it's doing so you can get a sense of how it's doing that. Format automagical stuff in the Vim auto command buffer hooks. Decent Vim plugin by REST for now. Actually, I'm gonna jump the gun and I'm gonna show you right now. So I'm gonna send you the line if you want it. So those of you who have Rust and want to use Vim for it, here is how you do that. I'll just give you a bonus since you're in the studio audience. I do the same thing as Go. So this is a Vim preleaf command that does any file that ends in .rs is automatically run through the Rust FMT tool before or immediately after it's saved. And then I'll send that to you with the eeks command. So there you go. Just add that command to your vimrc and you're good to go. You'll get automatic Rust formatting. Not too hard. All right. So back to what we were doing. So here's what the code looks like. It's a great reveal, right? It's pretty intense. I gotta tell you, I had to look all of this up. I mean, I had to look it up. I was searching like crazy at every stage along the way. Printing hello world is not too hard. And in fact, I wrote that in the walkthrough here. Here's printing hello world is pretty easy. It's just fn and then main, and then you just do print l. It's called a macro. It's not a function. Did I get that right, Rust people? You correct me if I get this stuff wrong. I'm new to Rust. Strings must be used inside of functions. So here we go. Here's the second version. It makes a string, and American Rust. So here we go. Println Rust hello blah blah blah, and we have name there. And so that's kind of like an FMT in Python, if you know what that is, or was it template? I want to say template strings in Node in JavaScript. ES6 added them. I really like them. I said we don't write syntax in the order of things. A lot of people don't. I'm going to reserve judgment on the language here. So here's how it gets a little bit easier, harder. So this is actually really dramatically different from Bash. I can't wait to show you. So in order to get any of the arguments from the command line, you have to load up the entire environment, which the environment is the environment in which the command is being run. And so you have to go get it. A vector here, in case you're wondering, I'm new to this, so let me show you the other one. So a vector is another name for an array. If you're a Java coder, you probably remember that's what vectors are. There's like I don't know, like 12 different ways in Java to do arrays, or to Python programmers, lists. There's lists and tuples in Python, and and there's arrays and vectors, and they're all different. They're essentially the same thing. There are a bunch of things in a line, sort of, that you can modify and add to and stuff. So this defines that it's a vector of strings, and this is template syntax. This is generic syntax, sort of. You might recognize from other languages, C# and C++ and stuff, which I'm interested to get into because that is a thing. This means that you can't mix up the types in this vector. It says this is only a vector. I think it is in C++. Yep. So I'm not a big C++ guy, but so this is STL kind of stuff, right? C++ doesn't have the STL. Isn't STL from C++? I think it is, right? The standard library. Yeah. So then we have like a whole bunch of strings. It says I have a list of strings, a vector of strings. Vector is a fancier word for list. In shell it would be called an array. And then we have to grab the environment arguments and everything. But Rust is going to probably play some. I agree, Mello. I cannot agree with that statement more. Even after doing this, it's still better than C++. So we're going to keep going here. So in order to change this variable here, and that's a little bit of a tutorial on Rust, but that's okay. It'll help you understand the difference between a compiled language that's strictly typed, such as Rust, and C++ would be just as hairy, by the way, but not much less than this. If compiled languages and strictly typed languages generally are more verbose. There's more things you have to specify and you have to know about because reasons. And Java's the worst. Oh my God. To do this in Java would be, is really verbose. Rust seems like C++ and Python mixed. It is. It seems, and Perl even. I mean, this right here, the U's up here, that's straight out of Perl, and this is Perl too. So there's been a lot of things that have been mushed together in Rust, and I don't dislike it. I tell you what I really love about Rust. One of my initial impressions is I love the help when you get things wrong. And I have a feeling that's because of because of the LLVM language. I've noticed that a lot of the LLVM language, particularly CLang versus GCC, right? If you're doing C coding, I'm not going to say I like one over the other one right now. But I tell you what, the LLVM languages have really wicked good syntax help. So like if you get something wrong, it will tell you. Like I got this if statement wrong. Check it. So I got this if statement wrong, and I did this with it. And I try to compile it Rust C, and see what it does here. Help remove these parentheses. I mean, look at that. It's like colored. It's like, really shows you right where it's at. It's got one warning emitted. It's like awesome. So there's lots of reasons people bag on Rust right now, but that is not one of them. I really, really love the compiler help. And yeah, I mean, isn't that cool? If you've done any coding before, G++ help is just as good as CLang as even code. That hasn't been my experience. But maybe something I don't. Wouldn't be the first time Mac. So you can use the standard iterator toolbox. Yes, questions how to access command line parameters. Yeah, that might be a different thing. Thanks for showing us that spiel. I'm just doing. I'm just that you're talking about assigning it. So I'm not. There's no doubt. There's a much better way to do this in Rust. But this is what I found through my minimal searching about how to do two things, three actually. How to look up the arguments, and this is the standard way to look up the arguments according to what I read, and to set a variable. And this mute, by the way, this is hands down my favorite thing about Rust. I overwhelmingly love this. Now, a lot of people hate it. I love it. Everything in Rust by default is read-only. Let me say that again. Everything in Rust by default is read-only. That means if you want to mess with the thing, you have to explicitly say, I'm going to mess with this. And the thing that's so cool about that, to someone who's been coding in lots and lots of languages over the years, is that you don't ever have a question about whether that thing is going to be safe. And that's a real simple way of stating the value proposition of Rust is that you have to explicitly say, no, I want this to be a mutatable. That mutatable is a fancy word for meaning you can change it. Immutable, it means you cannot change it. And it should work well. Nth args or nth count works well. Oh wow, thanks for that, Spills. Let me do that right now. Rather than getting all the args. In this case, you're saying I could have done it down here probably, right? I'm guessing. Args, instead of doing args as a vector, I probably could have done. Could I have done this? Well, since it got you here, we obviously got a Rust programmer here, which I am not. I'm going to take my advantage of them. I'm going to use them. So I guess we could say arg. I don't know. Arg name. I don't know. I'm going to go back to my other one. I don't want to confuse myself yet. But I am definitely going to go look up that possibility. In fact, I'm going to put it to do in here. Oh, I just learned that comments are backslashes in Rust today. Today I learned. That's just great because that's the way Go's are too. In fact, there's a lot of similarities with Go I didn't expect to find in here. So to do, all right, so change to this. All right. So you satisfied? Thanks for the input. So change to blah, blah, blah. Yeah, they are pretty standard, but you know, there's languages that don't do it. Anyway, so yeah. Anyway, so this is what I'm trying to tell you is what it does. So it has mutability. It checks to see if the length of that means the number of the list is more than one. It has to be one because why? Because the 0 counts. A lot of people don't know that when you look at your arguments, that includes the name of the script that was run. And some languages will let you change it, and you can actually pass on status to people looking at the PS output by changing $0, you know, the first argument. In Unix and Linux systems, they used to use that all the time to give status about a running daemon sometimes. Even if you're writing a quick and dirty little string, you can do that way. Oh boy, I broke it, didn't I? Thank you very much, people. You're like, no, please change it back. You have a bug now. Coffee Stein. Yeah, my wife brought that. So anyway, point taken. Lots of code. Don't let it scare you from Rust. My greatest complaint about Rust when I first came to it was this is not a language for beginners, and I maintain that. Rust is not a language for brand new coding newbies who've never written any code ever. In fact, a lot of people disagree with me. They also think they should learn, you know, vanilla Rust is vanilla Arch is their first thing for as a beginner. I disagree. You know, not even, you know, Harvard agrees with that. They teach you Scratch. We just had a guy go through this actually, CS50. And then the next thing they learn is C. And they try to make the case that C is the same as Scratch, which they struggle with. And I can attest to that firsthand from people that don't get that. But the point is that you want to start out somewhat easier. A lot of people think that you should learn an interpreter language first. And I actually am sort of changing my tune on that. Because when you learn an interpreted language, you don't learn about types, and you could inadvertently learn things. So even though I don't like Java as a first language, and that's the common first language for, you know, a lot of education, AP computer science in America is Java, but Java. The one thing that you do learn in Java is about types, and you learn to think about everything in terms of type. And the one thing that's nice about Rust is if a beginner were to learn Rust first, they would think about everything in terms of is it something that is going to change, and, you know, mutability and stuff like that. But yeah, so a lot of beginners who learn Python, and Guido van Rossum himself, this is in the Discord, said, I'll try to quote him. He said, the one thing that you learn over time, let's see, I think he said the sad reality. What was it? I can't remember, but it's that, as programs get larger, the need for strict typing increases, and he says that in terms of, he's talking about adding TypeScript, you know, typing to Python, because Python needs stricter types, and not having strict types is causing Python programs to become problematic as they grow. And I have another big video about that, about why interpreted languages are falling out of favor, and that's largely the reason. Unity, for example, and this is a quick, relevant side note. Unity, the game engine, originally when it first came out, it had a thing called Unity Script, which was JavaScript, and it had another language that it supported called C Sharp Mono, and you talk to Unity people today, and they're like, it actually had a scripting language, and like, yeah, it did. So because it failed miserably, I don't think it's a stretch to say that Unity Script overwhelmingly failed because so many people were writing bad code with bugs in it because it was this loosey-goosey interpreted language built on JavaScript, and I'm not faulting JavaScript for it, versus a strictly typed language. They started added types. I remember, 3.8 is the one. But yeah, AI too. We're not having a language war here. I'm just trying to tell you the difference between interpreted and compiled. So more and more game developers chose C Sharp because it's a very strict, sort of traditional class-based object-oriented programming. I don't like calling it an object-oriented programming because it's not. It's class-based programming. And so when you see that, you see why it won, right? Because larger projects do better with compiled / strictly typed languages that force you to tell the computer more about what's going on so that it can help you and protect you from yourself. You can say, no, dude, you're trying to put the letter Z in, or the word, the into a number. You can't do that. And so the compiler can tell you, you're bad here, bad, don't do this. And depending on the language, it might let you do that. You might end up getting really weird results that end up in people dying or losing money. And if you don't believe me, Spaghetti Code Kills actually killed people. Toyota Camry lost the lawsuit because Spaghetti Code in the assembly had caused deaths. So we actually want to make a t-shirt that says Spaghetti Code Kills because it does happen. And why does that happen? Spaghetti Code happens because you're not thinking about things, because you're just adding more to it over time. And so a compiled strictly typed language prevents code maintainers from making really serious mistakes by just tweaking something incorrectly and causing a value to be wrong or something like that messes up all the code in ways that are very subtle that might not be caught. Anyway, Go, actually, there's a big Go to, if you, Mello, if you're interested in that topic about Go and AI, I was very surprised to find kind of randomly somebody posted a blog about TensorFlow being ported to Go, and now a lot of machine learning people are like clamoring to use Go for AI. So there's a post in the Go channel on our Discord. You can go check it out and read that if you want to. I've been predicting for a long time that Go is going to take the place of Python for most of machine learning and most of cybersecurity because of its cross compilation ability and its ability to be much more portable than Python. So we won't fight about it, but I'll just mention that to you right now. Go is another compiled language in case you were wondering. So there's kind of a subtext to this whole video, and that is we are now in the age of compiled languages. It's really clear that interpreted languages are being told to stay in their corner and to do what they do best, but don't you come over here in our corner, because we are the kings of large applications and complex things that have to be distributed and not break and memory safe. And the compiled strictly typed languages are kind of like asserting their dominance in that space, which is kind of nice, actually. C could never really truly do that because it was a fail on so many levels. I can't even tell you all the levels C failed. And the reason it did is because it was never intended to be written by common people who don't fully understand memory management and all the things that go into coding in C, which has caused C that were dangerous to be used with C, even though it can be done very reliably. Brian Cantrell very explains this very well. And is it time to rewrite the operating system in Rust? There's a video where he talks about that, and he perfectly nails this topic. I won't add anything to what he has to say. It's very, very good. It's very well worded. And the conclusion I'll spoil is that no, it's not. Rust has a specific place, and it's not there in terms of rewriting operating systems, even though Gamozo, one of my favorite streamers here on Twitch, regularly writes operating systems in Rust. In order to do his fuzzing, which is breaking code on purpose to find out how to break it reliably. Anyway, so enough talk about compiled languages. If I've lost you, that's because maybe you're new to programming and you're like, oh my God, stop scaring me away from programming. This can't possibly be this hard and this complicated. Yes, with great power comes great responsibility. That's a great way to say it, Lakshan. But what I want to show you is something that's a lot happier. Okay, so we're going to leave Rust for a bit. We're going to talk about my favorite interpreted language on the planet, emulators, operating systems. I don't know. I saw him writing an OS once. Wait, we can look at that later. No, he wrote it. He wrote a Rust OS, and he was running it in a virtual machine on a hypervisor. Yeah. Anyway, I'm not. Look, I'm not. I don't want to bag on C too much. I think everybody should learn C as well because it's the most prolific, most important language on the planet. Every other language was originally written in some form of C and then moved on from there. It's also much better if you're doing embedded devices. People are still doing a lot of coding in C, although Go, TinyGo, and there's a bunch of Rust stuff too that's entering the space of IoT kind of small device coding. It's going to be very interesting, particularly because there's a couple large game studios have announced they're not going to do any more C++ development. They're doing all their game development in Rust. So Rust has not really hit the mainstream yet, but there are a lot of people ramping up, announcing version 2s of their applications, InfluxDB. A bunch of others have started to pick up on it. So the wave is forming. Make sure you're learning it. If you're, a prescient technologist and you want to keep ahead and connected with what's emerging, so you can catch that wave. And that includes me. I'm not a guy who chases trends. I pride myself on not chasing trends. I don't think Rust is a trend, and I think you should learn it, if for no other reason, to help you think about how you write code much differently. Arduino is still very much C, yeah. Rust for microcontrollers, also Python. Yeah, there's all kinds of stuff out there. Don't get me wrong. People will squeeze the right tool, their favorite tool, into the right tool. I mean, everybody uses like big, huge Phillips screwdrivers and then rips the crap out of the screw head, right? Because we're using the wrong tool for the job. But we made it work. Dude, it worked. Technologists are really good at doing that. We're really good at taking our favorite tool and then just like, everything, fixing everything with a hammer instead of the right tool. I'll leave that alone for a bit. So let's look at an interpreted language, okay? So yeah, Unreal does use C++ and Visual. So we're going to go and we're going to look at Bash now. Bash is hands down my favorite language on planet Earth because I can get so much done with it. It triggered me so hard. I wrote about it in my blog, robs.io, if you want to read my blog, my personal blog. Be ready for lots of swear words and ranting. Fish, I think Fish is cool. We'll talk about that. But another day. I can't talk about Fish right now. We're going to talk about Bash right now. So Bash is, this is not really a language comparison other than is a demonstration of what an interpreted language looks like versus a compiled language. And we talked about, lots of other examples of interpreted language. Let's just name a whole bunch, studio audience. What's your favorite interpreted language, right? So people who don't know what that means, let's name them. So Python is interpreted, Perl, Awk, JavaScript, Dino, TypeScript, Ruby. Oh yeah, Ruby's a big one. Scheme is Lisp. All of the shells. So Z shell, TC shell, C shell, Fish, FISH, Bash. They're all interpreted language. Well, what does that even mean? FMMPEG and C. Yeah. Okay. So Scheme is a good one. So all of these languages have one thing in common. They have an interpreter, and the interpreter for Bash is on the system. You do which bash, and if you look at the source code of bin bash, you see, and VI is one of the few things that can do this without croaking. You see that it's an ELF binary. By the way, this is another reason pen testers and security people love VI, because they can look at binary files internally. And that's not a thing. In fact, the NeoVim project decided to take away vimdiff. They took it out of the source, which is really stupid decision. So anyway, so let's look at that. So that's how you can look inside of the code, and obviously it's not anything you would read, but it does kind of help you determine. It's not the best way to determine the type of a file. The best way to do that is the file command. So bin bash with file, and we'll see what it is. It says it is an ELF64-bit LSB shared object, blah, 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 blah. Linked, dynamically linked interpreter. Wow, that's quite a bit of information. By the way, let's look at what Rust C was. So to do that, I'm going to do file, and then I'm going to do a which Rust C as a compiler for Rust. So there's where it lives. I love that Rust, by the way, puts its stuff in a local binary. It doesn't require installation on the overall system. It's one of the best advantages. Rust has really been made by people who appreciate good coding practices, and so far I've been really encouraged by that. It is overly complex for a beginner, but there's a lot of really solid design decisions they've made. Learning to read binary has been proving helpful. So here we go. We have Rust. It's also an ELF64-bit binary LSB shared object, dynamically linked interpreter. So it's an interpreter. Okay. So Rust C is an interpreter, but what it does is it interprets the language and then it spits out a binary, so that when we do when we look at the other one, and I'll go back really quick. Rust challenges. Hello. So then when we look at file hello, we see, what do we see? We see that it is also an ELF binary. And actually it tells you it's dynamic. That's interesting. It tells you it's got an interpreter. Oh, it tells you what interpreter to use, I guess. Huh. Actually, it's not an interpreter, obviously. It's an ELF binary. So this is the most important part, that it is a shared object, though, that's dynamically linked. And this is something I want to get into later. This is more of a in the woods kind of, in the weeds kind of topic. But to any of you, coders out there who might be beyond beginners, I'm super interested to understand dynamic linking versus static linking in Rust. Because Go is, of course, everything is statically linked, and Rust really boasts a small runtime because it does maintain dynamic linking, if that's what you want, but you can statically link, as you can do with C and C++. So that's an advantage of Rust that I really, really want to look at. Makes it much more low level as a language, much more low level than Go. Go is more of a Python competitor than anything else. So anyway, let me go back to where I was. So we're back into Bash here. Let's talk about something else to add to your path. Yeah, well, no, I'll probably move the program to the path at some point. So let's go look at the Python one though, and this is where things get really funny. So the really great thing about an interpreted language is that interpreted languages are simple to write, almost always. If you think about how easy it is to write JavaScript, but in this case, Bash is just like really awesome. So all 10 lines of Rust, if you take out the shebang line, which is meant to tell you where the interpreter lives, without the interpreter, this code can't run. And I could even go as being lazy. I don't know. Not really. I think the reason Go does that is for practicality mostly. Yeah, and I'm a big Go fan, so Go and Rust, I like them both. They have different purposes, in my opinion. But I think as I've said before in my blog, I do find that Rust and Bash are kind of squeezing Go out, and Go kind of fits in the middle. Go and Python definitely share the same space for me, and so Python, I don't use it at all. There's no need at all anymore. I can't even imagine a reason to use it. Maybe if I were back doing automation. So this isn't a language where I don't want to do that. So anyway, the thing that's really great about this, I could even take this line out. Why? Because I'm running Bash, right? Because I'm running Bash, I don't even need an interpreter on the shebang line. So I can just run it. So that 10 lines of code in the other language, in Rust, is one line of code in shell. And we'll call it Bash because this is definitely Bash. I lost my syntax highlighting. That's why you have to have a shebang line, by the way. This is called a shebang line. It tells you, it's a hint to your computer, to your Unix or Linux computer, that says, hey, there's the interpreter. Go send this whole file to that interpreter line by line and do what it says. So it is very much an interpreter. It sends each line to the interpreter, and that line is translated and interpreted by Bash, which I showed you, is a binary, and then it sends that interpreted code as system calls into the kernel, and you can watch your program running. And at that point, it's just like any other program, machine or otherwise, machine code or otherwise. It's a series of system calls that go into the kernel and then are translated by the kernel to do actual things to the devices on your system, your file system, which messes with files, your screen, everything is file in Unix and Linux. And so that every program that runs is translated into system calls at some point. And if you become a pen tester or anything, a second level support guy, I did this for IBM a lot, you'll have to watch all of the system calls and find out what went wrong. And sometimes it's kind of an insight into something that's been compiled that you don't have code for. So that's just to tell you that interpreted languages are a lot simpler. They're almost always Python's horrible for automation. The automation people write in Python is garbage, not portable. Probably true. I can't confirm that. I haven't done automation with Python in since 2011. 2011 is the last time I wrote Python automation, and I did it with Fabric. So that was a long time ago. PHP can be interpreted. PHP is not a language that was intended to be run as an interpreted language, but it can be run as an interpreted language. In fact, I know that because I tried it at IBM on a major project to be a good citizen because everyone else was coding in PHP on the front end. I found a massive memory leak, several massive memory leaks in the PHP runtime that caused me to throw it all away, 2 months of work, and rewrite the whole thing in Perl, which I should have done in the first place. And if I had Python at the time, Python was not there. But if I had another language, I would have done it. So there are some languages that can be run as interpreted languages that are not particularly designed to do so. In fact, one language very famously, what is it? What is the most famous, not Hyperledger, nope, it's a different one. So what is the most famous language that did not start out as an interpreted language on the command line, but then became such? That's an easy one. JavaScript. No, Pascal. I don't know. I know enough about Pascal. So JavaScript, right? So Ryan Dahl, bless his soul. Love him. Love Ryan Dahl. Make Dino. You guys need to check out Dino. Deno. Dino.land right now. He just came out with version 1 about a month ago, and which is his answer to Node, which he complains about in his 10 Things I Hate About Node conference talk, which is so funny. I recommend it to everybody. So the inventor of Node, which is JavaScript on the command line, basically fell into it on accident. So let's actually write one right now. Hello, JS. So we can do this. Let's see, user. Let's see, Ben Dino. I wonder where my Dino is. See, I should know this. I'm gonna get in trouble here because I'm gonna do something that I normally don't like to do. Which is not, yeah, see, I have to, this is something I still disagree with that these guys do all the time. They do user bin env Dino, which I hate. I hate doing that. It's so indirect. It's so unsafe to do that. But that's what a lot of people do now. So, and then you can do console log, console.log, hello. And no, I don't need a stinking semicolon. Just be quiet. And so then I can schmod that. Actually should be schmodable already. Schmod, let's see, schmod. U plus X, hello JS, / hello JS, and you get Dino. That's interesting. Or is it valid in this context? What did I do wrong? What did I do wrong? No. Nope. Wow, I'm coding live on it and something I haven't coded with in a long time. Wait. I'm sorry. All right, give me a sec. Magic wand command coming up. There we go. I don't think so. I don't think you do. If you're going to tell me that I have to have a JS extension to run a Dino script, I will immediately abandon it and never use it again. Mm. Well, I do know one way this is definitely going to work. Dino hello.js. Hello.js. Are you telling me I actually have to have... No, Dino is the interpreter. Yeah, if I put node there, it would work, right? Which Dino? Dino? This is gonna get a ticket issued right away if this works. So Ryan, if you're out there watching, don't you dare make me have a suffix. Please, dude. That is like so not nice. Nope, that's not it. This is a version 1.0 and I'm playing around with it in real time on YouTube or whatever. On the YouTube/Twitch. What's going on, people? Help me code. Help me with the codes. I don't think it is the... Dino is a JavaScript interpreter. That's what I'm really confused about. So watch. So you can run Dino like this. And there you go. Console log. Hello. Hello. There you go. I mean, it does it. I know it's working. No, it's not semicolon. I just proved it. I just proved that it's not a semicolon right there. So, you know what it is? I think it's because we don't have access to console log. No, we just proved that that's not true either. Do you need a shebang? This is a shebang. And that's the Dino line right there. That's what I'm trying to say. That is the Dino line. Let's see what's in the Dino. This is good, guys. Oh, and it's an elf binary, so there you go. So Dino, I think I'm doing everything right. Is it Dino run? I think you might have it. You think you might have it. Yep, that's it. Okay, smart man. So Dino is not an interpreter. Who knew? I didn't know. All right, so please, God in heaven. Yes. Okay, good. All the permissions are executable. They are executable. See? Compiled a little under the hood. Yes, that's true. It is. It definitely is. And we won't show that. I was just trying to show. This does concern me though, because this means we can't run command line scripts. Actually, that might be consistent though with Dino, because Dino is you know what? I didn't mean this to be about Dino, but Dino is an interpreted script, so interpreted language, and we are talking about interpreted now. I already gave up how easy it is to do it in Bash. I don't think we can add run to the shebang line. I thought you would put run on the end of the shebang. That seems really weird to me. If that's what is Dino? Dino is the replacement for Node, built by the guy who made Node, called Ryan Dahl. You can dino.land to read all about it. It hasn't taken off yet. It's been written in Rust. The entire thing was written in Rust. It was originally written in Go, and now it's all been written in Rust. The entire language interpreter written in Rust. It also has a V8 runtime for JavaScript that you can put into Go. It's pretty damn cool. And Rust. They have a JavaScript runtime you can embed in your Rust code, so you can actually create languages, other things that use JavaScript and TypeScript as an embedded language within compiled Rust applications. Super freaking cool. So I know I'm going like kind of all over. I'm just kind of having fun here, but let's do this one now. So Dino run. I have a feeling this is going to work, but I kind of don't want it to work. So, yep, there you go. So there you have it. You can actually have and I'm almost positive if I do this, which is, I'm sure, Ryan's preference. I don't like using user being env. It's insecure. And there's lots of other reasons I don't like it, but it's really common to do that these days. Oh, there you go. Look at that. That makes me happy. That makes me really happy that I can't use Urbini env run Dino. That makes me wicked happy. So here we go. Which Dino, bang bang bash. And put this over here. I'm going to add run to the end and make something better with vision. Dino, you know what? He has the courage to own his mistakes publicly and say, please guys, give this other thing a try. How cool is that? I wish we could all do that. GNU not Unix. Yeah. So anyway, there you go. That's how you run it. If this had been Node, you know, you could do the same thing with Node. In fact, I can do the same thing with Node here. I can just do shebang. You guys know about Node, right? I don't know where my Node is though. Is it Node.js or Node? That's always a problem. There. Oh, user bin Node. So yeah. Now that's another one. So that one actually should work too. Except for I have two shebang lines in there. It doesn't know what to do with it. Oh, it's what am I doing? I'm such a dummy. All right, there we go. So hello, Jess. There we go. So Dino supports TS. Yes, it does. Dino has full support. How's it going for TypeScript? So I actually think Dino has a really bright future. One of the coolest things about Dino is that it is the only interpreted script that runs in an entire dealing as a scripting language. Interesting. Dino is the only interpreted script I know of that runs in a full sandbox, which means you have to explicitly give it access to your file system and to your network stack and a bunch of other stuff. Super cool. So yeah, Cat, what are you doing? Cat Tenfu. What am I doing today? Well, right now I'm talking about interpreted versus compiled languages, and we're actually wrapping up the difference between the two. Multiple arguments of shebang. Yeah, I don't know if I want to read it right now. All right, so the takeaway here is interpreted languages are easier to write, they're faster to write, but they're also generally less safe, particularly for large code bases. And this is a really good example of why you would use an interpreted language. Every time, I'm going to say this again, I say it all the time, anytime you use a shell of any kind, you are coding in an interpreted language. You're writing interactive code. Every command you enter is a line of code. And if you put that same line into a file, it becomes a script as soon as it gets an executable permission to allow it to run. At that point, you are writing code. So your terminal, I actually discovered this a couple of months ago and started changing the way that I teach as well when I started teaching Bash as a first language. Because anybody who's using the terminal, and they should be using the terminal, everybody should, is already coding. Every time you run anything on the command line interpreter, you are running lines of code the whole time. So I encourage you strongly to learn, be it Bash or Z Shell or POSIX or PowerShell. Learn your shell language, because your shell, it's named shell, by the way, because it is, you can imagine an outer ring, a shell between you and the inside kernel of the computer. The shell interprets the commands from you and from other programs, and then sends those, commands to the kernel as system calls and other things. So that advances up. So that's how your computer works. So next time somebody asks you, just to recap as we wrap up today, if you have any other questions, get them queued up because I'm going to answer them. But as you can tell, interpreted languages are faster to write, but a little bit less safe, and they don't run as fast in general, and they also take longer to run, usually longer to start up. And I do want to show you the stats on this. This is a tiny little execution speed, and compiled languages that are harder to maintain because they are longer to write, but they're safer to maintain, and they are generally more robust. They can generally take on bigger scopes, larger projects, and as soon as you need a larger language, you probably should trash any of the interpreted languages if you're going to do a big project, and start to do it, particularly now, because there's so many options. And this is, by the way, this is the reason I feel like Python is falling out of favor across the board. It's enjoying kind of a heyday. It has for the last year or so. But I kind of think it's going to get dethroned here because it is really the age of compiled languages these days. Easy to write, safe compiled language is really where it's at. And that includes Go, Crystal, Julia. And on every level, there is a compiled language that is your favorite domain language. R, these are all compiled languages that are that are much safer and more robust to write, but yet you can write in almost as quickly as you can write in interpreted languages. So the space between compiled languages like C before and Shell, the original interpreted languages were like Shell and C, and there was nothing in the middle, right? In fact, Perl came along and kind of, it wasn't really intended to be in the middle, and people adopted it in the middle and started using it. Python, PHP, a bunch of other stuff in the middle started to evolve. And then it kind of moved away from that. We had Java in the middle of that, which was both interpreted and compiled, which I'll talk about another day. And then but we're kind of moving away from that because the compiled languages are creeping in, and the interpreted languages like Bash and Dino are getting more and more powerful. And so, because you can use TypeScript, right? TypeScript is solidly in the compiled space because it's a very strictly typed language. TypeScript is strictly typed interpreted language. It's one of the first ones ever. So the idea of having that, and it's so impressive that Guido himself cited TypeScript as a reason for adding strict typing to Python in upcoming versions, even more than he already is. So the world agrees that we need a product. We need languages that need types. They need the option of having strict types for larger projects, whether it's interpreted or it's compiled. The world agrees on that, and so we're starting to see interpreted languages have strict types, and we're also seeing, compiled, fast, awesome languages become easier to write and safer to write. And those languages, like I said, include Go, Rust, and the gang. Yeah, no npm with Dino at all. That's probably one of its biggest claims to fame. Dino actually took one from Go and decided to use direct module inclusion from Git repos and stuff for its imports, which is just exquisite. I can't tell you how. Cargo Rust, I think, does kind of the same thing. I think though there's still a repository for Rust, if I remember right. I'm new to Rust. Don't blame me for not knowing it. I'm learning it. So this has been kind of an overview of interpreted versus compiled languages. Hopefully the journey has been fun and educational. I'm going to turn the fish back on and take a break. But I'm retrieving a couple questions here. Godot allows C# too, but a lot of C# tools are, yeah, C# is a compiled, strictly typed language. Not really much else to read here. Thanks for your participation. Thank you, studio audience. And I'm going to take off. See ya. Serious Rust projects. I do too. I'm not saying don't use Cargo. I never once said that. I'm saying to get to the core of the language and learn it. I don't think you should jump in with Cargo the way the book does, personally. So my mini projects will not have anything to do with Cargo. And then, because I want people to get into the habit of compiling, because then when they go to C, they'll understand what's going on. Cargo hides too many of those things from people. Okay, so let me go ahead and do a Twitch.